Okay, this is our last packet for Module 6. I changed the numbers because I added in an extra packet, but I forgot to change them on the notes. So this is now Lesson 5, although all the notes say 4. So sorry, I'm not going to change them on every page, but this is a really long packet. If there's stuff that is redundant, then I'll try and cut it out so this doesn't go on forever and ever, but we'll do the best we can. I just want to make sure you're super ready for the Module 6 test. So we're going on a trip to the Grand Canyon. So we're taking a trip, which is 225 miles. So whenever I get stuff that's important, I like to underline it. I know that's probably going to be important. You will fill up your car with gas, and the gas costs $3.50 per gallon. Your car can travel 200, or hello, I wish 200, right? 22.5 miles per gallon. So every gallon of gas, the car can go 22.5 miles. So we need to know how many gallons of gas we'll need. Well, it has nothing to do with price. So we know this first question, we don't need to look at that. So we have 225 miles and we get this many miles per gallon. So hopefully you understand that this would be, I always think of it as miles per gallon. So per means divide. So miles per, and that's how many we get on a single gallon. So miles per, how many miles we get on a single gallon. And when we take out our calculator, 225 divided by 22.5 is 10. So we're going to need 10 what? So you look at the problem and it says how many gallons? So we're going to have to purchase 10 gallons of gas. Use the table below to determine your total cost for each whole number of gallons of gas used. So in other words, 0, 1, 2, 3, 4, those are whole numbers. So 0 gallons used, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to be able to write an equation for this. So the cost is going to equal the number of gallons, because this says total cost, times the cost per gallon, right? So the total cost will be how many gallons times the cost per gallon. So here we're using 0 gallons times 350. Hopefully everybody knows if you use 0 gallons, it's going to be $0. For this one, we're going to use 1 gallon. 1 gallon times 350 is $3.50. 2 gallons times 350 is $7, and on and on. So let's just keep adding 350. So this would be 1050, and then double that, that would be 14. And then add 350 would be 1750. And then add 350, that would be what, 22? And sometimes if I'm not sure, I just go, well, let's see, 6 times 350. Let's do that on the calculator and see. So 6 times 3.50, boom, 21. Whoop, see? 21, not 22. No booming here, right? And then we have 350, which would be 2450. and 28 and $31.50. And I think this would be $35. So I'm just going to check real fast and make sure all my calculations are correct. So 350 times 2, yep, that's 7. Then I'm going to hit the up arrow, make that 3. Yep, that's 1050. Hit the up arrow, make that 4. 14, yep. And hit the up arrow, key over and make that 5. Whoops, too far, Kim. And 1750, hit the up arrow, make that 6. 21, and hit the up arrow, make that 7. 2450, hit the up arrow, make that 8. It's looking good so far. And then hit the up arrow, make that 9. 3150. And notice sometimes your calculator gives you this. Don't ever write that for money. Money is 2 decimal places. So 31.50. The calculator doesn't know you're doing money. That's why it doesn't give you the second decimal place. But I would count it wrong, and so will Alex, if you write 31.5 for money. Money is always 2 decimal places. And then up arrow times 10. 10, and that gives me 35. Looking good. Okay, so our table's done. On a separate piece of graph paper, create a graph where you will plot the number of gallons of gas used on the horizontal axis and the total cost for that number of gallon on the vertical axis. Label each axis and give a title for your graph. So we do have a graphing problem on our next test. So it goes with a word problem. So go to your, I think it's 1 to 3rd page, and you will see graphs. So pull out that page. I just took my staple out because that packet was so big. Whoops. Whoa. Hit the camera there. Okay, so let's see what it says here. So on a separate sheet of paper, it says to number of gallons on the horizontal axis. So here's the horizontal axis. Number of gallons. So you do have to label it, and that's one point of every problem is labeling the axes. So the x-axis should be number of gallons. So number of gallons, I guess we should say of gas, since they told us to. And they already put the numbers in for us. So we have 1, 2, 3, 4, and we're just going to go up to 10. And next it says, and the total cost for that number of gallons on the vertical axis. So here let's write total cost. And when you make a graph, you do have to, you tell the units, because I don't know if this is in yens or pesos or dollars. So you do have to always label it with what the units are we're using. Be sure to properly label each axis and give your graph a title. So shall we call it Trip to Grand Canyon? Since that's the top of this page. Trip to the Grand Canyon. And giving it a title is one point of your problem as well. So Trip to the Grand Canyon. I guess I could have just said Grand Canyon trip. Made it a little bit shorter, right? Okay, so now we have to look at cost. So we have to go from, I'm trying to show both of these in the same screen. We have to go from 0 to 35. So we need to decide what units to use on our graph. So if we went by fives, what would it be? 5, 10, 15, 20, 25, 30, 35. We could do that. So that might be the easiest. Go by fives. And some students think whatever you do on the x-axis, you have to do the same thing on the y, and that is not true. So you can label each one separately. You just always have to start with 0. And if this is 1 unit, then that can only be 1 unit and that. For instance, you can't go 10, 15, 20, 25. Each box has to count the same. So counts as 5, counts as 5. So 15. And some students will label each of these, but as long as we have this labeled here, you don't need to put the $sign because that's already evident by your units. 25, 30, 35. And that's our highest number, so we can stop there. So now we have to plot the points. So we have 0 goes with 0, so that would be right here. 1 goes with 350. Well, 250 is half of 5, so it's going to be just a tad bit above half. Oh, let me move this down a little bit. 2 goes with 7. So 2 goes with 7, so 5 right in the middle would be 7.5, so not quite middle, just a little underneath. And you'll notice that this is going to be a straight line, so as you're graphing your points, just make sure they're lining up nicely. 3 goes with 10.50, so just barely above $10. Should be 3. 4 goes with 14, so just a little bit below 15. 5 goes with 17.50, so 15, 17.50 would be right in the middle of 15 and 20. 6 goes with 21, so we'd just be barely above 20. 7 goes with 24.50, which is just barely below 25. 8 goes with $28, which would be a little over half, because 27.50 would be in the middle, so that would be 28 about. And I'm just making sure my points are looking like they're in line. 9 goes with 31.50, which would be a little bit over 30. And last but not least, 10 goes with 35. So there is my most beautiful graph. Okay, what is gather my papers here. What is the input quantity? So do you remember input is the X? What is the input quantity for the graph? What is the output quantity, which is the Y? So let's write input first. So we learned input are the X values. So what's the quantity? Number of gallons of gas. Or you can look up here. Remember how we learned the first column of a T-table is always the X and the second column is the Y? So we could say gallons used, or we could say number of gallons of gas, either one. So I'm going to use what we wrote on the graph. So number of gallons of gas. What is the output quantity? So look on your graph, total cost in dollars, or look on your T-table, output is the Y, total cost in dollars. And almost every word problem is going to ask this question. What's the input? What's the output? So input is just whatever you labeled your x-axis. The output is whatever you labeled your y-axis. So I would highlight those just to remind yourself what they are. So input X, output